Hello all. Today I'm going to be showing how to do a calibration curve using Excel. This is to help you with your phosphate lab and to do your data analysis correctly, make sure you got everything done correctly. That way you can write your lab report. You can include this curve we're going to include there in the results section. So let's just go ahead and get started. The first thing you want to do is just kind of go ahead, start labeling everything out. I'm going to just go ahead and start label column 1. That's my concentration. Next, we're going to have, remember I made you do 3 trials. You measure each standard 3 times, so I'm just going to do trial 1, trial 2, and trial 3. All right. Eventually what you want to do is want to get an average of this. And then you want to convert that average. Remember, if you remember, Beer's law is the relation between concentration and absorption, and what the instrument was measuring, it was measuring transmittance. So you want to convert your transmittance to an absorbance value. So I'm just going to label right here the last one, absorbance. All right, now I'm just going to make everything fit correctly. Right. Another thing you might want to include that I forgot to include it here is your units. So I'm going to say that this concentration was in ppm. You might have molarity, have ppvs, whatever you decide to use for your concentrations. Let's enter that out. And then absorbance. Absorbance does not really have any units, but what we do to describe that last value, we use absorbance units, so AUs. Alright, so now, and this of course is going to be an average of your percent transmittance. Alright, so I'm going to make some theoretical values here just to kind of show you what you kind of should have gotten or what you should be seeing with your data. So I'm just going to start with, saying with my blank. Remember, your blank has 0 concentration. This is kind of like a starting off point. So I'm just going to go 0. Then I'm going to do 1 and just double the concentration every time. So 2, 4, 8. And I'm just going to do one last one because I need 6. I'm just going to do 10 at the end. Alright, so after you got that, you're going to go ahead and introduce your data. Now, if you remember, if your concentration is 0, then all your light should be going through. You should get a 0 absorbance value. Alright, which makes sense. If there's nothing in there, if there's nothing supposed to be there, there shouldn't really be any absorption. Therefore, all your light should go through. So I'm just going to go ahead and label all of those 100. Oh, let's go back up. There we go. All right, and then you just kind of want to fill in the rest of the data. So I'm just going to add some values here. So let's say, as you normally see with this instrument, you tend to see some fluctuations. So I'm just going to add that, incorporate that here. Place. Alright, so once you added all your data, you want to just go ahead and do your calculation. Now, the neat thing about Excel is that you can just go ahead and do the calculations on one of them, and then you can apply the same calculation throughout, so you don't have to do it every single time. So all you have to do is just click on that cell. You want to do equals. That means you're going to start writing an equation. You want an average equation, so there it is. Right? And then you're going to select your cells that have the numbers you want to average. So you just click and drag. You're going to close your parentheses and just click enter. Obviously, if all my values are 100, the average is going to be 100. Now, I'm just going to go ahead and click on that corner. You'll see that corner you see is kind of a little bit more bolded. You're going to want to hover over it. you'll see this plus symbol. You want to click and drag down, and that will automatically do the averages of all your different standards. Now, last thing you want to do is convert that to absorbent units or your absorbance. Remember, the relationship between transmittance and subsorption is the negative log. So we have the absorption equals the negative log of your percent transmittance, percent T, divided by 100. Right? So all you're going to do is now you're going to plug this equation here, but I like to have them here on the side so I know what each column is doing. So I'm just going to do equals negative log right? Now I'm going to select my average transmittance, so which is in this case going to be 100 over 100. Go ahead and close my parentheses, hit enter, and you see that I get it 0, which makes sense. If all the light is going through, that means 0 is being absorbed, therefore the absorbance is 0. Alright, next, same thing as before, you just want to hover over that little darker greenish corner, click, and drag down. Right, so now you actually go ahead and calculate all the absorbent units for all of them. Now something, and this is just a little bit thing you want to keep constant. You want to keep constant your units, number of significant figures. You see this gives you a lot of decimal points, and really we don't have that much accuracy. So I'm just going to reduce everything down to just a few. I'm going to say this is a number. Right, and that looks a little bit better, so I only want 2 significant figures for this last value here. Right, so now I'm going to go ahead and start building my calibration curve. Right, so what I'm going to do is I'm going to select any 2 columns for now. Right now I'm just going to select the first and second columns A, B. Right, I'm going to go to insert. You're going to insert a scatter plot. I do not want any lines going through it. I don't want any connecting. I don't want this big bubbles. You can't really tell anything with that. I just want a regular plot like that. Now when you initially do this, if you have the same setup that I have, it'll do a relationship between concentration and your trial 1, and you see this is normal. You see that as you increase the concentration, the lower the transmittance, which makes sense. There's that you have a higher number of particles absorbing that light. But we don't want to look at that because this is more of the logarithmic scale. The actual relation is going to be with the absorbance. So, hey, look at that. Now it looks something a little bit more linear. Right? Now, things you want to do to this chart to add it, make it a little bit better is, well, the things that you need to have. You want to add a trend line. And there's 2 more things you want to add. So you're going to click here, click more options, and you want to set that you can see the R² value, and you want to see the equation of the line. Make sure when you do this that you're selecting a linear trend line. You don't want to get a logarithmic or a polynomial. You want a linear because this is a linear relationship. This is due because of Beer's law. If you remember Beer's law, it's absorption equals your concentration, right? Times your molar absorptivity, I'm just going to do E, times your path length. I'm going to do P, or actually let's do D for distance of path lengths, right? Now, if we relate this to our calibration curve, remember the linear relationship of a calibration is going to be Y equals mx plus B. Right? So if we see the relation between these two, let me actually just move this guy, move it here. Right? If you see these two kind of look very similar, we have like a plus value at the end. That's just because of the fluctuations you see. It's not perfect. It doesn't make a perfect accurate measurement, but if you see, if we would have started, it would have been at 0, 0, and if I hover here, it's 0, 0. But because of fluctuations of their instruments and what your measurement, it gives you this value here at the end. But if we take that out, then it's just y equals mx. Remember that your distance that you were using your cuvettes, you were using 1 centimeter cuvettes. So anything times 1 is just itself. So that's actually the pathing gets automatically incorporated, if you would, into your calibration curve. But anyways, the relation we're getting for this one is we have a sum plus b value we have to deal with. So we know that y is going to be our absorption. M is actually the molar absorptivity, and X is going to be your concentration, because that's what we're telling the graph to do. This bottom here is your concentration. So let's go ahead and label that. This is concentration. And I'm actually using ppms. Yes, I am. Alright, and this is my absorbance. I'm just going to do abs, or let's just do AU for absorption units. I probably shouldn't hit enter. It's messing up a little bit my graph. Click here, delete that extra space there. Oh, I did it again. I can make this bigger so we can look at it better. Alright, so there he is. What you want to see is you want to see an R square value that is really close to 1. The closer you are to 1, the better it is. Sometimes you see a little bit far deviations, not a big deal. You can still use the equation to calculate for your unknowns. But otherwise, the closer you are to 1, the better your result, the more accurate, more precise your results are going to be. All right, so you did have 2 unknowns. So I'm going to say unknown 1 here. Let me just actually continue. So I'm going to do unknown 1, unknown 2. Right, and hopefully measured that 3 times as well. So I'm just going to make up some values here. Right, and you see if it automatically applies, went ahead and applied my formulas I was applying before. Right, so let's do the other one. Let's just say it was. Right, and it went ahead and did the calculations for me as well. Now, the numbers at the end is what you want to be using. Plugging in as your y, and then solving for your x. So let me just write here all the values. So this is going to be my y's, right? This is m, my slope, my molar absorptivity. This is my b. And finally, what I want to calculate is x, right? So if I'm going based on my unknowns, right, my y value, my absorbent values was that guy for the first one, and it was this guy for that. And you can do what you just saw me did, what I just hit equals, and click on which one I want, or you can just go ahead and type it in. All right, there we go. Now the slope of this guy, so I'm just going to write it here, is 0.0914, and B is 0.0046. All right, so using these numbers is what I want to use. I'm actually going to let's flip these two. Move that down really quickly. All right, so first thing, if you remember from general algebra, if you're solving, if this is your y value, this is your b, this is your m. First thing you want to do is subtract. It's a plus value, so you want to subtract whatever, or add if you're in case that was a negative value. But this case is a positive value, so we're going to go ahead and take our y value, so it's going to equal our y value minus this guy. All right, and let me actually just do this in one whole calculation so it's a little bit easier for you to see. So if this is our y, this is going to be our x. Let me do, now let's go ahead, it's going to be equals my y value minus my b, which in this is going to be minus because it's a plus, like I said. So 0.0046. All right, let me put that in parentheses, because then I want to divide that by my molar absorption, which is 0.0914. Alright, and that should automatically solve and give me what my concentration was like. I can actually just drag that down and do the same for the other one. So if we look at this, we can actually compare, right? If we look at unknown 1, we get our transmittance balance around like 13, 14, 12. It looks like it's between these two guys, right? And we have between 8 and 10. It's telling me that it's actually a 10.2. And for this guy, we see that it's a 76, right? So it's between these two. So between 1 and 2 is actually 1.15. So those are the concentrations of your unknown in ppm. So hopefully that helps you calculate your unknowns, to help you with how to make a calibration curve. If you have any questions, don't hesitate to contact your TAs. Hopefully this helps. I'll see you next time.